Hello, my name is Alan White, and my pronouns are he and him. I'm the president of DataPerf Professionals, which is a small consulting firm in Cleveland, Ohio. Welcome to my session, Find So You Can Fix Those Troublesome Queries. First off, there are a lot of things that PASS has to offer, from training and networking to local user groups. There's SQL Saturdays, there's PASS marathons, there's all kinds of activities going on all over the world for you to check out. Please do so. There's just so much that PASS has to offer that's well worth your time. When we're done, please take time to fill out the evaluation. The feedback is really important to us. We want to make sure that the information that we give to you is valuable to you. You're getting the most out of your sessions. So also, if you submit before Friday, November 20th at 5 p.m., there's prizes to be had. So please take the time to fill out this session evaluation. A little bit about me. As I said, I'm the president of DataPerf Professionals, a firm I started about 2.5 years ago. Just a small consulting practice. I've got a couple clients in the Cleveland area, focusing mostly on outsourcing DBA services, doing query tuning, that kind of thing. You can reach me on LinkedIn at AlanW2. My Twitter handle is at SQLRUNR, SQL Runner. You can reach me at my email address, awhite@dataperfpro.com. Just a little bit about me. I've been in IT for a very long time. I actually started working in IT in 1974. And yes, it was punched cards and feeding the cards in and to a computer system and getting reports back the next day. I went through a lot of changes through my career. Started off in computer operations, moved into development where I was a programmer until the early 90s. I discovered in the early 90s SQL Server and started working with it in 1992 and have been working with SQL Server ever since. In July of 2007, I was awarded Microsoft's Most Valuable Professional Award in SQL Server at the time. Now it's the data platform specialty. And I've been awarded that for every year for the last 14 years. It's a singular honor. What it really means is we're giving back to our community. And that's what makes it so special. What you learn from me is important to me, and it's important to Microsoft. And they kind of reward those of us who do this with the MVP award. And we get special privileges like meeting with the Microsoft product teams and talking about the things that they're doing, the things they're going to do, and we also get insight on the things they've already done. For 3 years, I was on the board of directors for PASS. From January 2016 through December of 2018, I was on the board of directors. I focused on programs, I focused on partnerships, but mostly I worked on trying to make PASS a better organization for all of you. I have had a tremendous career, largely because of my association with PASS, and hopefully you'll find the same thing for yourselves. Let's get on to the session. The abstract for this session is that every expert has their own set of tools they use to fix and whatever problems they run into on SQL Server. A lot of those are vendor supported, but SQL Server provides all kinds of information for you to solve your own problems and to troubleshoot where those problems actually are. They come right in the box, and we're going to talk about those. This last quote comes directly from Grant Fritchie, the immediate past president of PASS. He says, "No magic will fix crap code," and it's absolutely true. No matter what you do, if the code isn't right, it's going to perform poorly. So let's see what we can do to find those things. We need it to follow a process. That process starts with observing behavior. What is the problem? What does it look like? We need to capture the metrics that tell us what is going on the server so we can see what things look like there. Those metrics include I/O counts, they include runtime stats, and most importantly, memory grants. SQL Server wants all of the memory it can get all of the time. So what is it that's asking for the memory so we can better resolve those problems? Once we have those metrics, then we're going to start working with the query and try to reduce the resources that are being used by that query in some way. Make changes to the query, run it again, observe the behavior, and repeat this process over and over and over again. This is how performance tuning works. And just accept the fact that it is an iterative process. And not only is it an iterative process in resolving the problem, but you have to come back to it periodically, because with the sizes of databases and the fact that there's growth in that data, the metrics change. Things change. There's a different distribution of data. There's all kinds of things that cause a query that runs really well today to not run it at all tomorrow. So you have to keep an eye on things. So our agenda. There are a lot of great third-party tools that are available from vendors. Those are outside the scope of the talk that we have today. Please take the time to visit the expo hall, visit with the vendors. A lot of them have great tools that will help you reduce the amount of time it takes you to do your job. We are going to cover Perfmon and Profiler. Yes, I'm going to talk about Profiler, and there's a specific reason for doing that. We'll look at the SSMS Activity Monitor, which used to be a tool that you would never fire up. These days, it's not such a bad tool. It's a good, quick way to find information. We're going to talk about the Performance Dashboard Report, which is in SSMS in version 17.2 and above. Hopefully now 18.7 just recently came out. I'll be running 18.6 in our demos. But by all means, use the tools that are there. We're going to talk a little bit about dynamic management objects, which are basically views and functions. And those have been inside SQL Server since SQL 2005. And most of the tools you're going to be using from third parties or built within SQL Server are actually using DMVs. We call them DMVs, dynamic management objects, under the hood. We're also going to talk about extended events. Not a lot. We're not going to get into a whole lot of detail, but I want you to see how easy it is to fire up a live event session so you can see what's going on your server. We're going to talk about the graphical query plan, because that is really the tool that you're going to use to diagnose what's going on your server. And lastly, we'll touch on a couple of the reports that are in the query store that will help you solve problems quickly. All right, so let's get started. Perfmon and Profiler. Yeah, Perfmon allows you to capture those performance counters, and it really is. It's been around Windows almost forever. Actually, a few years ago, I was presenting at a user group session in Brisbane, Australia, and a guy came up to me afterwards and said, "Yeah, I'm the guy that wrote Perfmon." I was floored, and I wish I'd gotten contact information so I could get some more story behind it. But it has been around for a long time, and it is the most consistent way to gather the performance counters that you want to watch. Once you've gathered that information, combining Profiler and Perfmon, you can view the results. Well, in Perfmon, you can look at the data in graphic or in text format. We're going to capture the results in Perfmon to a file, and then we're going to bring up Profiler, and we're going to capture the workload, And then we can use Profiler to combine those two result sets and see them together. All right. One thing you never ever want to do is run Profiler to capture live activity. As opposed to extended events, which we'll do later on in the session, Perfmon actually has a pretty significant performance hit if you're capturing live activity in Profiler. All right, so best not to do that. What we're going to do is, I'll walk you through this, is use a server-side trace, and we'll save that trace data to a file. Then we'll view it in Profiler from the file, and then we'll tie those two together. So let's take a look at the demo. All right, now we're going to join the Perfmon and Profiler data together. First thing I want to do is go into Profiler and generate the transact SQL we need to create a server-side trace. You can do that flat out in T-SQL, but I find it's easier to let Profiler create that SQL for you. So I'm going to open up Profiler. I'm going to start a new trace. We'll connect to our server. We'll call this Pass 2020. And then we're going to use the T-SQL replay template. The T-SQL replay template was created so that you could capture a workload and then replay that at another time. How I've used that before is I've taken a database backup and then run a workload on a server, capturing the replay information, the replay trace information. Then I can restore that database backup to a server, run that trace data as a workload, and look at the performance of that. Then I can restore that database to another server and load that same replay workload, run that, capture that performance data. Now I'm comparing the two servers using the exact same workload, the exact same databases, and I can compare apples to apples with regard to which is the better server to do this. I've done this a number of times in the past, and it's very effective. In this case, all we're trying to do is join the Perfmon data to the Profiler data, and the replay template gives us all of the information we need to do that. We need to run this trace just for a brief moment. We'll stop it right away. And now, because we've run it, the export option is available. If you don't run the trace, the export option isn't available. So export it, script the trace definition for SQL 2005 to 2019. And we'll put this into our demos directory. We'll call it Pass 2020 replay def. If you notice, there's already a file in there for replay trace def. I've created that for you. It's in the downloaded that I provided. All right, so we've saved that. We'll close out a Profiler for right now. We're going to create a server-side trace. A server-side trace is the least damaging, if you will, the least impactful from a performance perspective that you can have, kind of trace that you can have on a server. So we'll go into our demo directory. We'll copy that file into SSMS. Now there's some changes we need to make. First of all, max file size of 5 megabytes really isn't big enough. So I change that generally to 100. I also change this parameter from 0 to 2 because if I don't, once we reach the max file size, the trace stops. I want to be able to roll over because I might not capture the performance situation that I'm looking for in the first trace file. Then we need to identify where we're going to write that trace data. So I'm going to put it into the C work pass 2020 replay trace file. I don't need to put the extension on it. You'll notice in the comments that come when Profiler generates the T-SQL, it gives you that comment, say it will tack on that extension for you. For right now, we'll leave this on hold, and let's open up Perfmon. So we're going to run Perfmon, and normally we go into the live capture of performance data, but I'm not interested in that. I want to capture a data collector set. We go into user-defined data collector sets, and this is a standard one that's included normally. But what I'm going to do is create a new one. We'll call this Past 2020. Create from a template. And then I've already created the template for you. It's an XML file. It's called healthcheck.xml, and it's in the downloads I've created for you. But I wanted you to see what it looked like. It's just an XML file that has the counters defined that we're going to collect in Perfmon and put into our Perfmon data. So these are the counters that I typically capture when I'm doing a health check on a customer system. So what we're going to do is browse into our demos directory. There's the health check template. Click next, and I'm going to move this also to that See Work Past 2020 directory. Click next, save and close, finish. Now we have the Past 2020 Perfmon data, Perfmon collector set defined. We can start collecting that data. You notice we get the icon, it's running. We'll come in here and execute the server-side trace. Now our server-side trace is running. It's trace ID number 2. We'll go into some really ugly queries that Adam Mechanic wrote to look at performance, to show really bad performance. Now this process takes 25 to 30 seconds to run. A couple of really ugly queries at the beginning, and then at the end is a small query that has a key lookup in it. A key lookup can be rather impactful on especially on CPU, right? But I wanted to capture one of those death by 1,000 cuts type of scenarios. So that query actually runs 10,000 times. That's done. So we'll stop our trace. How do we stop our trace? Almost the same way we started it. I'm going to copy this trace set status command. Our trace ID was 2, as you can see in the window down below. And 0 stops the trace, and 2 removes the trace. And then we can go in and stop our Perfmon collection. And you notice that's stopped now. All right, back into Profiler. We'll open up SQL Server Profiler. And instead of starting a new trace, what we're going to do is we're going to open a trace file. That trace file, we said, is going to go into the Work Past 2020 folder. There it is, Replay Trace. There's our trace data with the activity that we've got, and our SQL text is way over here on the right. Because we captured a replay, used the replay template, and Profiler recognizes that all the information is there that it needs, the Import Performance Data menu item is enabled. So we can import that performance data. We'll navigate there, and it says, okay, here are the counters I collected. Which ones do you want to see? I like to keep this to a minimum, because if you put in too many counters, you end up with a mosh that looks really pretty on the screen, but it doesn't allow you to easily see information you're looking for, right? So I'm going to go into general, no, not general, it's SQL statistics, batch requests per second. So I'm just going to look at processor time and batch requests per second. And now I've got an interesting graph, and where I really like this tool is I'm going to click on that peak of the blue line, which is percent processor time, takes us to another really ugly query. right? If I click over here on the peak of the green line, we're in the middle of our 10,000 executions of our key lookup query, right? So this is a way for you to tie the counters you see in Perfmon directly to the activity that you're going to see from the trace in Profiler. I wish that they would create this capability using extended events in Azure Data Studio. I've asked for it, and it has been put on a back burner. There just isn't enough interest in that, but so until then, I will continue to use this method to be able to look at the Perfmon data in conjunction with what I see going on in the SQL workload. All right, next, let's take a look at Activity Monitor. These are tools that are built into SSMS that are available for you to use right now. Now, Activity Monitor is a tool that in earlier versions of SSMS I would never touch because it was rather impactful on a system performance. A lot of improvements have been made, and I encourage you to take a look at it. You can filter processes by session ID, by user or system processes, whether it be a login or database. You can filter out what you don't need to see so that you can focus on what you do need to see what's going on. You can look at resource weights, data file I/O, and any read-write activity, the latency types scenarios. And what I find very useful is recent expensive queries, because what you're really looking for when you're doing performance analysis are what is it that's going on my system that's taking all of the time. So your recent expensive queries and your active expensive queries are both very, very useful tools that will allow you to isolate those problems and correct them. So let's take a look at that demo. To get to Activity Monitor, we simply right-click on the name of the server and scroll down and select Activity Monitor. The graphs at the top are great if you've got Activity Monitor open a lot. I don't generally recommend keeping Activity Monitor open a lot, but while you're looking at things, it will track the percent processor time, the waiting tasks, database I/O, and batch requests per second. Some of the information we captured in our last demo, but it will show you this on the graph for your own use. We can click on processes. We can scroll through all of the processes that are running on our server right now, and we can select either user processes, which it now defaults to. We can look at just system processes. Sometimes a system process is what's causing the problem. We can select all, so we can see everything that's together. Normally, we're going to be looking at user processes. So, we've got a login, we've got our database, we've got the state of our task. You'll have to open these up a little bit. What is the command that's being run? The application. One of the things I find very useful is to be able to say, okay, who's connecting with Management Studio? And you notice I've got 3 sessions here connecting with Management Studio. So I can isolate who's doing what and where. I can also say, instead of going by that, somebody's complaining there's a problem with a particular database. All right, who's in AdventureWorks? Just these 2 sessions. Who's in AdventureWorks 2008 R2? There's 1 session going on. This is the activity that's going on. Well, see, now it's jumping around because I've actually got Jonathan Cahias' workload generator running from a PowerShell window. So it's doing a whole bunch of querying, which is what the activity is that you see in the graphs up above. So we'll go back and we'll select all of the databases. You can sort. We've got wait times, wait resources, the amount of memory used. So this particular query is taking 32K versus the other queries that are taking 24K. So just by clicking on the column header, you can sort and group all of the information together that's important to you. So you can see AdventureWorks there, 2008 R2 there, right? So the ability to use this processes dialog is very useful. If we want to look at resource weights, here mostly we're dealing with network I/O, which generally tells me that it's like SSMS is will show up as network I/O because there isn't enough activity. SSMS doesn't respond to the incoming data quickly enough. Similarly, an application will cause the same thing. Now it jumped into logging, right? If I want to look at the data file I/O. Now there's not enough I/O going on in my workload to really show some things. Let's, just for fun, run our really ugly query and see what that does to our process. It's executing. Remember, it took 25 to 30 seconds to run. So all of a sudden you see our percent processor time jump up to 51%. That's an indicator that there's something going on that we should probably take a look at, right? So we can look through the processes and see what processes are running right at that moment in time. It's still executing, so is there any, well, look, there's a bunch of data file I/O now, TempDB especially, but in the other databases as well. Active expensive queries, it has completed, so there's no queries active, but recent expensive queries. Here's our query that does the key lookup. How do I know that? The execution times, 10,002, versus another query. And what's really useful about this is I can right click and say edit the query text, which gives me that look, or let's go back to we can show the execution plan. Oh, why did it fail to retrieve? And we can look at the execution plan. Now I'm going to go into execution plans at a later time, but it's real easy to bring up the execution plan from a particular query just right directly from Activity Monitor. So hopefully I've shown you there are a number of tools that are built into Activity Monitor that are available for you to use right now. Now we're going to take a look at the SSMS Performance Dashboard Report. Now this was introduced in SSMS in, I think, version 17.2. It's in the Reports tab when you go into SSMS. And it is extremely useful for a quick look at what might be going on your system. There's graphs that show you things like CPU utilization and the waiting requests. A waiting request typically will show up if you've got a lot of waits going on. So you've got some real problems going on. Current activity, what's going on right now on your server. And then a variety of drill down options, waits, latches, IO states, expensive queries. All of these things are available to you via the dashboard report. So let's take a look at that. To get to the Performance Dashboard Report, what we're going to do is we're going to right-click on the server, and we're going to scroll down to Reports. We go to Standard Reports, and right there at the top, just so you can see it, right there at the top is Performance Dashboard. So we'll do that again. reports, standard reports, performance dashboard, and it now runs the report and gives us our graph. You notice this is kind of similar to what we saw in Activity Monitor for the performance of the CPU. Like I said, I don't have a lot going on this server, but I've even looked at this on a production server, and unless there's a significant amount of waits, you don't often see a lot of waits in the current waiting requests graph. But what I can do is I can click on the link there for waits, and right now it's showing the most significant number of waits is Query Store. Again, this is a demo system. It's not a live system. But you see I've got a significant number of parallelism waits, other type of waits, preemptive waits, and I can open up, say, preemptive, and here are the individual waits, the number of them, the wait time, percent wait time. So there's a lot of useful information for you if your problem is what is your server waiting for. If we go back to our high-level report, we can look at latches, we can look at I/O statistics. So you can see TempDB is 99.36% of our I/O. That's really not a surprise given that anytime we're doing anything with any complex query, SQL Server is probably spilling to TempDB, and then it has to go back and get that information back again, right? The top 20 objects within each database responsible for the physical I/O. I'm going against sales customer, sales order header, human resources employee. These are the objects that I'm hitting the hardest from an I/O perspective on my system. So we have that information. We can look at expensive queries by CPU, right? And it gives us this graph, and so we can target in and we can click on that high number, and this is actually a monitoring tool query, interestingly enough. But we click on number 2 here, and this is our work order. This is our key lookup query, right? So that's an expensive query that we're dealing with. Another one that we're dealing with is that another really ugly query. Remember, that was when we did the Perfmon and Profiler together, and we looked at the peak CPU. It brought this query back up. So we can drill in to see what queries are running on our system, and then drill in and hopefully do some performance tuning of those really nasty queries. But I find this useful. We can say by, okay, what's reading the most data? It's this really ugly query, right? And here's the data behind it to show you that. What's our longest running query, right? Well, first of all, it's this extended events session. But after that, our longest running query is this one with the work order, not necessarily because it runs long, but it's looking at the total execution time, and it's been run on this system like 30,000 times already. But here, total number of executions is 5, and our CPU, cumulative CPU, is 17 million milliseconds. So it's a way to drill into your system to see what queries are causing you the most pain, and then allowing you to go and correct that so you alleviate that pain. And this is built in, and this has been around for a little while, but it's not been well publicized. So take advantage of great tools like that SSMS provides for you. The next thing I want to talk about is dynamic management objects. I will consistently refer to these as DMVs. That's how Microsoft introduced them when they introduced them in SQL 2005. They're dynamic management objects because there are views and functions, but I'll continually refer to them as DMVs. They've broken them out and they capture information about what's going on in the system, about almost every aspect of the system. So we've got transactional DMVs giving us information about the locks, active transactions just for a particular database. In this case, indexes, we can see what indexes are being used, how much of the indexes are being used. It's in this index usage stats that we can find out information about the fragmentation of those indexes. When they get overly fragmented, we can see performance problems from that. The operational stats, how much they're using those indexes, the physical characteristics of those indexes. It will tell us about what indexes the query processor thinks are missing. It could do a better job for your query if you fix or add these particular indexes. Please don't just arbitrarily apply whatever the missing index DMVs tell you, because they won't always look to see if the same index already exists on a table, for example. But it'll give you the details of those indexes that it thinks it can use to create a better query plan for you. It'll tell you what columns, it will group them for you. Those are useful DMVs to have. Also, if you want to understand what the query plan is, let's say you didn't turn on the actual query plan when you ran your query. Well, SQL Server has to create a query plan for every query you're running, and it will put those in the plan cache, and these DMVs will go into that plan cache and bring back information about the queries that it's been running from the plan cache. It'll give you the SQL text and the query plan itself and statistics on the runtime information going on with that. So let's take a look at a couple of the queries we can use directly with DMVs to take a look at what's going on in your system. Lewis Davidson and Tim Ford wrote a book a while back called Performance Tuning with SQL Server Dynamic Management Views. And the queries I'm going to share with you today come directly from their examples in their book. And I've provided a link at the top of this script, which I've provided in downloads for you, so you can go get the book because it's free from Redgate. So yay, Redgate. And you can go through their book and see these queries and a lot more that will make you much more effective at using the DMVs. This first one, we're going to say, okay, let's take a look at wait times. There are a lot of wait types that are really irrelevant to the performance, and you can ignore them when you're doing wait analysis. In fact, if you go to Glenn Barry's website, every month he puts out an updated set of DMV queries for you to be able to use for troubleshooting on your own system, and his list of wait types that you ignore is significantly longer than this. But just to take a quick look, here we've got the wait types in descending order by wait time that are affecting our system, and we can take a look. SQL Skills has a good reference for what each of the different wait types mean. So check out their site to understand what the wait type is, whether or not it's important to you, and then use that information for troubleshooting performance on your own system. Another case, we would like to bring out query plans. So this query itself will bring back the SQL text and the query plan. When we execute it, there are some plans that actually exceed the maximum depth in an XML document. So that's what that error was. But for the most part, you're probably not going to be running a query that does that. But we've got here the query text. We've got the batch query plan that has everything in the batch, or a single statement query plan. We click on that, we get the query plan we looked at. Actually, this is the one we looked at earlier. So it's a quick way to get from the plan cache the query plan for queries that are running on your system right now. If we want to look at queries that are expensive to your CPU, we're going to look at the exec query stats DMV. And so this query will give us the top 3 most expensive CPU queries. And here's that one that I run 10,000 times, right? The execution. Well, okay, so we're at 20,000 here in this case. But this is a way for you to be able to quickly, without even using any other tool, just go to the DMVs and get the information that will help you isolate the queries that are causing your performance problems. In addition, a lot of times people will complain about locking and they don't know what's being locked. Well, let's take a look. We're in the AdventureWorks database and we're going to begin a transaction. We're going to select from the product category table and update that information. But we're going to leave that transaction open. So one row is effective, but it's still, that transaction is still open. We can use the DM translock DMV and bring back, and let's zoom in on this. We've got an exclusive lock on product category, intent exclusive locks on the pages where that key lives. We've got a schema lock on the metadata for the AdventureWorks database. We've got a couple more exclusive key locks, and on the product category object, an intent exclusive lock. So by using this DMV, I can see what locks are actually being put in place so that I can better tune the workload so that we don't have deadlocks, because that's really what we're trying to avoid, right? So let's roll back that transaction. So if I run that now, we won't see those locks. We'll see some shared locks. All right, let's talk about extended events. Early in this session, I talked about Profiler and Trace, but those have been deprecated, right? What you really should be using, unless you're in the use case that I showed in the first demo, you should be using extended events. It tracks events in SQL Server. It's far more lightweight than Trace. You can filter, and in Trace, the filter that you can use, SQL Server will still capture all of the data, and then it'll throw away the things that aren't in the filter. Whereas in extended events, when you create a filter, it filters that before it captures. So again, it's far more lightweight. The Trace events are fixed. They're not going to add any more events. That's fixed at 180 events. SQL 2017, which I'm using at my client site, over 1,500 events in extended events. So a lot more information than you can capture, and it's far more lightweight. And if for those people who really like to watch stuff as it's really going on, the live data window that you get in SSMS will allow you to watch what's going on as it's happening, right? So let's take a look at that. To use extended events without getting into the T-SQL, and I'm going to let Aaron Stellato talk about, and Jonathan Caius talk about how you can really use extended events. They're the best people for that task. But shy of that, what I'd like to do really short in a short period of time is show you how relatively easy it is to open up extended events. I'm going to go into Management, Extended Events, Sessions, and I'm going to create a new session. And we're going to call this session name Pass 2020 just because I like that. Templates. If you remember when we talked about in Profiler, you had templates. You've got the same kinds of templates in extended events. In this case, I'm going to use the tuning template because from when I'm actually doing performance tuning, this template brings back the events that most frequently give me what I'm looking for when I'm trying to tune queries. Start the event session immediately after we create it and watch the live data on the screen as it's captured. Whereas you never want to do this in Profiler, it's perfectly fine for you to do this with extended events. For the events, because I chose the tuning template, it brought back RPC completed, SP statement completed, and SQL batch completed. The one thing I want to do though is I only want to watch the information going on in the AdventureWorks database. Now, if you remember, I've got this workload going. That's going nonstop. That's in the AdventureWorks 2008 R2 database. I only want to look at the activity in the AdventureWorks database. So I'm going to highlight those events, click on Filter here, and I'm going to add a clause, and I'm going to select SQL Server.database name is equal to AdventureWorks. In data storage, I need to have a target for my extended events. And normally I pick event file. It gives that file a name based on the name I selected for my event. It's past 2020. And that's fine. It's going to have a maximum file size of 1 gig, and it will roll over 5 times. So that's significantly bigger than what we did in Profiler earlier, and plenty for what we're going to do today. Once I've made all my selections, and I'm not going to get into the advanced tab, it's beyond the scope of this presentation, I'm going to say OK. And I'm going to run the really ugly queries so that we have information. Now you see we have live data going on. We're capturing. By default, what's going to come into your session are the name and the timestamp. But down below, you see there's batch text. And if we scroll all the way up to the top, there's too many to go on. Because we're watching live data and I'm executing 10,000 times, so it's filling up my window. I'm gonna stop this session. Okay, so the session stopped. Now I can choose columns because, well, before I even do that, you notice there's a bunch of information down here. I'm going to scroll all the way up to the top. See, I've got SQL batch completed. Here's another really ugly query. But I would really like to see that up top. So I'm going to, I think I can drag that. Nope. All right, let's just choose columns. And I'm going to choose the database name. I'm going to choose duration. Logical reads is always a useful piece of information. And I want batch text. Now I have all of this information at the top. You see the duration here for, and this is in microseconds. So it took 4.9 seconds to run, 5.2 seconds to run. This took about a half a second to run. But all those little ones, they take 1 millisecond. But there's a lot of them, right? So that they do impact the performance of your system. So that's the death by 1,000 cuts. But I can see that But you notice all of my database names throughout the entire thing are just AdventureWorks because I filtered on that. Extended events didn't capture anything but that database, the information in that database, even though I still had all this activity going on. It didn't capture any of it because I wasn't interested. I'm only interested in this particular set of information. I can sort on logical reads, or I can sort on duration. There are all kinds of capabilities in using this data from this live query window. You can group. I already showed you the sorting. You can select which columns you are. At the end of the deck, I've got a link to a video that Grant Fritchie did that goes into a lot more detail on what you can do in this live window. And I highly recommend you take the 7 or 8 minutes it takes to watch that video. You'll find a lot more usefulness out of extended events just using this capability. I'd like to talk about Graphical Query Plan. This is probably the most important tool you have in your toolbox to determine where your performance problems live. That query plan gives you the details of everything that the query processor is going to do in resolving your query. It gives you estimates of the amount of data it's going to use at each step, and if you choose the actual plan, which technically isn't really an actual plan, the estimated plan is what you're going to do. Let's just say the actual plans are estimated plan with runtime statistics. So that's what it's going to give you, those runtime statistics that it used when it was resolving your query. And all of that information is going to help you resolve how to hopefully write a better query that will run faster. Let's take a look. Let's take a look at the query plan for this another really ugly query that Adam Mechanic provided for us. I'm going to just highlight that and select Display Estimated Execution Plan. And now what we have here is a graphical query plan that tells us what SQL Server is going to do, what the query processor is going to do to satisfy that query. And you can listen to any argument you want to, whether to read left to right or right to left. I always start on the right because this is where the data comes from, and it moves left as it goes through the process of satisfying that query. Right? So it's going to do an index seek, and it's going to estimate an IO cost of 13, a subtree cost of 15. The number of rows per execution is, what, 2.6 million. The number of rows to be read is 4.3 million. Right? So this is what the query processor thinks the job is going to be based on its estimate, based on the query that we gave it. Right? It's going to send that through. It's going to split those the results into a couple of different paths to hopefully use the multiple processors to speed up the process. It's got to segment that data, and it's going to send that to a TempDB because it needs to send that to TempDB to do its work. And then we're going to do an aggregate, and we've got a nested loop to bring back together more information from our spool. And we've got a bunch of nested loops here, and then we're going to gather those streams together into our final select. That's a lot of work. When I see those table spools, that's something I'm concerned about. Is there a way of fixing the query to eliminate that spill to TempDB? So there are a variety of ways of approaching the query. And what I look in here is find things that stand out. Things like key lookups especially. I always look for key lookups because there I've got an opportunity to potentially build an index that covers that query to eliminate that key lookup. But going through the graphical query plan, and there are a lot of good sessions. In fact, Hugo Cornelis had a full day on execution plans. I highly recommend you go to Hugo's site. He talks about the details of the query plan, and You'll learn a lot about the internals of SQL Server, and you'll be able to write better queries because you understand what it's going to do, and you can help it do its job better by writing better queries. The last thing we'll talk about today is Query Store. It is like a flight data recorder for your queries. It's been available in all editions of SQL Server since 2016 SP1. You have to enable it in each database that you're going to use it. And for the most part, you're pretty safe to do that. There are some use cases. I will refer you to Aaron Stellato to give you details if you have a situation like you've got an incredible amount of really tiny queries that you're running, but like nonstop all day, that might be a use case where you want to leave it off. But for the most part, I leave it on at my clients, and it's extremely useful. The data that it collects, it persists in tables in your database, so that when you back up your database and restore it someplace else, for example, all of that query stored data is available. So take a backup of your production system and then restore it on another system, and you can explore what's going on with each of your queries from the query stored data. You can use catalog views to look at the data. I find that the reports that come with SSMS are plenty to guide me to what's going on, right? And it captures both plan store and runtime stats for the queries that are running. Extremely useful. Let's take a quick look. I've turned on Query Store for the AdventureWorks database. So we're going to open up AdventureWorks, and because I've turned it on, I have the menu item here for Query Store. So I'm going to open that up, and it gives me a number of reports. The first one I always go to is the top resource consuming queries. And that's where I'm going to stay today. All right. So I've got some, number 2 is this query. That's an ugly query and another really ugly query. Remember in graphical query plans, we just walked through this. The original ugly query is even worse with all of the activity that it's doing. Clustered index scans, seeks, hash matches. There's all kinds of activity going on there that is useful for you from a troubleshooting perspective. This number 1 for total duration is that death by 1,000 cuts query that I talked about before that has the key lookup, right? So I can see by selecting these copies of the execution of that query in my history that have a large duration, I have that key lookup in there. But then I added a covering index to cover the columns that are in that query, and I ran that query with the covering index. All it had to do was do the index seek. You can see the performance time was significantly lower, and I didn't have that key lookup, which leads to CPU contention, right? So just using this report alone from Query Store helps me see a problem and fix the problem, and then I get the proof that what I did to fix the problem actually did fix the problem. So anything more than this, there's a lot of information out there. Again, Aaron Stellato, Jonathan Cahias, Grant Fritchie talks about Query Store. There's a lot of people that talk about Query Store. There's a lot of in-depth information available to you for using Query Store. Use it. It's there, and it's built into the product. All right, we covered a lot of ground in a short period of time. I've got a bunch of references for you to check out. By all means, do so. Brad McGehee wrote a book a long time ago on mastering the SQL Server Profiler, where he goes through the steps to be able to join the Perfmon and Profiler together the way I did in the first demo. So check that out if you're interested in it. A whole book on SQL Server execution plans by Grant Fritchie. Check out, and it's free from Redgate. Just download it. I mentioned when I talked about the extended events using the live data window. This is a link to Grant's YouTube video that shows you exactly how to do that and more in depth than what I provided today. Extended events posts from both Jonathan Cahias and Aaron Stellato are available at SQL Skills with using the key search term extended events. Again, information on the query store from Aaron Stellato, SQL Skills, Query Store. And then down at the bottom is a link to the free book from Redgate by Lewis Davidson and Tim Ford on dynamic management views and functions, aka dynamic management objects. Download the book, download the examples, take a walk through them. You will find you'll be much better at performance tuning. Thank you so much. Again, I'm Alan White. You can find me on Twitter at SQL Runner. You can reach me via email at awhite@dataperfpro.com. I look forward to seeing you and talking in the comments.